All right, so we've taken a look at level 1 encryption, which is basically just storing the password as plain text in our database. So maybe it'll be a little bit difficult for people to get access to our server and access our database. At least you can't just simply right click on a website to view page source and be able to see it in the HTML. At least it's stored at server level. But that's not really good enough. So let's go ahead and see what we can do to improve the security for our users on our website. So let's increase to level 2 authentication. And level 2 authentication involves the use of encryption. So what exactly is encryption? Well, basically, all it is just scrambling something so that people can't tell what the original was unless they were in on the secret and they knew how to unscramble it. This is exactly the same as if you and your friend were sending each other secret messages and you had a key to encode the message that you both knew so that you could decode the message. Now, on a bigger scale, if you've ever watched The Imitation Game or read about the Enigma machine, well, that is basically a form of encryption. And the Enigma machine, if you don't know, is just simply a machine that was used during World War II. When the Germans would send each other messages, they would use the machine to encrypt those messages so that when the messages are intercepted, say over the radio, unless you had the same Enigma machine and you knew what the decoding key was or what the settings were for the machine, then you wouldn't be able to tell what it is that they were trying to communicate with each other. If you're interested, I really recommend watching 2 videos that were done by Numberphile on YouTube. And I've linked to it in the course resources list, but it explains the Enigma machine and it talks about the flaw in the Enigma machine that led Alan Turing and other people at Bletchley Park to be able to crack the code and create what was very much a specialized computer to be able to decode those messages and helped the Allies win the war. And if you ever visit London, be sure to go and check out Bletchley Park, and they have a computer museum next to it as well, which is super fascinating. Anyways, I digress. So back to ciphers and encryption. One of the earliest ways of encrypting messages that we know about is the Caesar cipher. And this comes from Julius Caesar, who was one of the generals in the Roman Empire. And what he did is he would send messages to his generals and he would encrypt it. So if his messenger got murdered along the way, then his messages would be kept secret. And this is one of the simplest forms of encryption we know about. And it's very simple. Let's say we have the alphabet, right? A, B, C, D, E, F, G. All that the Caesar cipher does, it's a letter substitution cipher. And the key for the cipher is the number of letters that you would shift by. So if you knew what the shift pattern was, then you could really quickly decipher the message. So if we were to encrypt the word hello, there's a really neat tool online that can help us do that. It's called crypty.com and it's got 2 I's at the end. And you can basically choose the kind of cipher or encryption that you want to use, and then you can specify the shift, and we're going to say a shift of 3, let's say. So if my text was hello, then it becomes shifted into core. And to an unknowing person and a non-cryptographer, it can be quite difficult to see at a glance what exactly this is trying to say. Now, in modern days and with modern cryptography, this is overly simplistic and it's very, very easy to crack. But there are other forms of encryption which are a little bit more complicated and it involves a lot more maths to make it more time consuming for somebody to crack. But essentially, all encryption works exactly the same way. You have a way of scrambling your message and it requires a key to be able to unscramble that message. All right, so now that we've learned all about encryption, it's time to go ahead and implement it so that we can encrypt our users' passwords on our database and keep it secure. So the npm package that we're going to use is something called mongoose-encryption. And if you take a look at the documentation, it's basically a very simple encryption package that works with Mongoose. So it's perfect for us. So it uses an encryption algorithm called AES, which is a relatively modern encryption algorithm, and it's far more secure than something like the Caesar cipher, which is very, very easy to break. Now, before we get started, I recommend you just have a quick read of the documentation here. This package does two things. It can encrypt and it can authenticate. We're only going to use its most basic functionality, which is encryption. And we're going to leave the authentication for a later lesson when we discuss things such as hashing algorithms. So as always, to begin, we're going to go ahead and install that package into our project. All right, so first things first, let's stop our server from running and let's go ahead and install Mongoose Encryption. Let's just make sure that we don't have any typos in that name and let's hit enter. So while npm is installing that package, we can go ahead and require it in our app.js. So I'm going to call this encrypt. And we're going to set it to equal require mongoose-encryption. All right, so now that we have the package required and installed, we're going to go ahead and use it. And of course, to figure out how we do that, we go to the documentation. So it briefly describes how the encryption actually works, and then it tells you how to get started. So we've got installation step, which we've already done. So now we're on to the usage step. So firstly, we have to require Mongoose and require Mongo encryption. And then we have to change our Mongoose schema a little bit, because notice that in their Mongoose schema, they're actually creating a new Mongoose schema, whereas ours is just a very simple JavaScript object. Now, this works as long as you're not doing anything fancy with the schema. But in this case, as you'll see later on, we're actually adding this encrypt package as a plugin to that Mongoose schema. So we're going to have to level up a little bit and turn our schema into a proper Mongoose schema object. And in fact, if you take a look at the schema section in the Mongoose documentation, when they talk about defining your schema, you can see that they're also creating a new mongoose.schema, and then they're creating a new object from that class in order to define the schema. So let's go ahead and change our very simple version of a schema into a full Mongoose schema. So we're going to type new mongoose.schema with a capital S, and then we're going to open a set of parentheses to enclose this entire JavaScript object. So one here and one here. So now this user schema is no longer just a simple JavaScript object, but it's actually an object that's created from the Mongoose schema class. So let's go ahead and hit save, and then let's see what else we need to do. So there's two ways of going about encrypting your database using this Mongoose encryption package. One way is to create an encryption key and a signing key. Alternatively, and the one that we're going to be using is a little bit later down in the documentation, which is why it's helpful to read the entire documentation. We're going to be using the convenient method of defining a secret, which is simply a long string, and then we're going to use that secret to encrypt our database. So let's go ahead and define that secret down here. So I'm going to create a new constant that's called secret, and this is going to be set to a long string that you're going to keep secret. So let's say this is our little secret. And now we're ready to use that secret to encrypt our database. And we do that by taking that schema that we defined earlier on over here, and we're going to add our Mongoose Encrypt as a plugin to our schema, and we're going to pass over our secret as a JavaScript object. So let's go ahead and implement this line of code in our app.js, and I'm going to put it right below here. Now, it's important that you add this plugin to the schema before you create your Mongoose model, because you can see that we're passing in the user schema as a parameter to create our new Mongoose model. That's the user model. But before then, we're going to add our encrypt package as a plugin. And if you have a moment to spare, do read the part of the documentation on plugins on the Mongoose website. And it talks about how essentially what plugins are is they're just extra bits of packaged code that you can add to the Mongoose schemas to extend their functionality or give them more powers, essentially. So now that our schema has this encryption power enabled, but what this will do is it will encrypt our entire database. Now, you may or may not want that kind of behavior for your database, because later on when the user logs in, we're going to have to search through our database to find their email address. It's best if we only encrypt the password field and leave the email field unencrypted. So to do that, we have to change an option for our Mongoose encryption package. And the option that we're going to change is to only encrypt certain fields. And they cover that in this section of the documentation. And to do that, all you have to do is to add this option, encrypted fields, into that JavaScript object at the end of that plugin code. So we're going to copy this little part here, and we're going to add it just before the closing curly brace. So right after our secret, right here. Now, in our case, the encrypted field is not age, but it's going to be the password field. So we're going to swap out this particular input with password. And that's just a simple string that you put in there that you have to make sure matches with one of the names of your fields. Now, if you wanted to encrypt multiple fields, you can also do that just by adding other entries into this array. So now that we've added our encryption package to our user schema, we've defined the secret that we're going to use to encrypt our password, and also the field that we actually want to encrypt, we're pretty much done. So we don't actually have to do anything else special in the register or the login sections, because the way that Mongoose Encrypt works is that it will encrypt when you call save, and then it will decrypt when you call find. So that means that when we create a new user with an email and a password and we call save, automatically behind the scenes, Mongoose Encrypt will encrypt our password field. And when we later on try to find our document based off the email that the user has entered, then at this stage, Mongoose Encrypt will decrypt our password field to be able to check it in this step and see if the user can log in. So let's save our file and let's go ahead and run it by using nodemon, app.js, and make sure that there's no errors on running it. Then we can go ahead and hit up localhost 3000 and try to register. So we've already created a user called 1at2.com. Let's create a@b.com now. And let's define their password as QWERTY. So the first 6 letters of the keyboard. And believe it or not, this is one of the top 5 passwords that's used by people all across the world, along with the actual word password and 1, 2, 3, 4, 5, 6. Now, if I have read out your password just now, please change it. While we're learning security, it's a good idea to update your own as well. So let's go ahead and hit register, and we've been taken to the secret page. So that means we've successfully saved our new user into our database. So let's take a look at that user inside Robo3T. So we can see that previously, when we didn't encrypt our password, it's just out there in plain sight. Basically, anyone can read this user's password. But now that we have added our encryption, you can see that it's now a very long binary string that is very hard for anybody to guess what it might be. So that means if somebody hacks into our database, they won't be able to skim everybody's password immediately like they can do here. So we've updated the security for our users just a little bit. So let's see how Mongoose Encryption handles decryption. So let's go back to the home page and try to log in our user, that was a@b.com, and let's put in their password, which was QWERTY. And let's go ahead and click login. So it's taken me to the secret website, and we know that on our database, that password is stored encrypted. So that means that when we perform that find one step, Mongoose Encrypt was successful in decrypting the password to be able to compare it at this stage. And if you want to, you can actually log the value of founduser.password inside the find one completion block, and you'll see it in plain text. So this does mean that if somebody was to hack into your website, then they probably will get access to your app.js. It's not that hard to access it. And once they do, they'll find your secret. And once they've found your secret, then they can use the same package to decrypt all of your users' passwords. So as long as we're able to recover the plain text version of our users' passwords, we're still kind of leaving them out to dry. So in the next lesson, I want to cover something called environment variables. And we're going to learn that to enable us to store secrets such as our encryption keys or things like API keys that are tied to credit cards, anything that you want to keep secure, essentially. So for all of that and more, I'll see you on the next lesson.